Hey guys, how's it going? So we're going to be doing some ordinary differential equations today. This was a problem that showed up on a quiz 2 years ago. I really didn't know how to do this back then, but now I still remember this problem today, and I'm going to approach this, and I know the answer. Y to the eighth derivative plus 8y to the fourth derivative plus 16y is 0. And at first, this question looks a little daunting because we only known like how to do powers like where this is at most 3, and usually the leading derivative would be like the second or something. So we're going to be doing this problem today, and I'm going to be showing you how. So the characteristic equation of this is obviously r to the 8 plus 8r to the power of 4 plus 16 is equal to 0. Yeah, and then what you do next is r to the power of 4 plus 4 squared is equal to 0. You could do this by substitution, maybe say r to the power of 4 is u or something, and then you could have figured this out. But I recognized it directly, so here we go. Obviously, this something squared 0, directly say r to the power of 4 is equal to -4. Now, you almost want to give up until you realize you learned some stuff in either linear algebra and or complex variables math course. So then say something like this. Z equals r to the power of 4, which equals -4. R to the power of 4, I'm going to write this up here. R to the power of -4, no, sorry, R to the power of 4, this is going to have 4 solutions, is equal to, on the axis, like that's 4e to the power of I pi. I pi. Yeah, because e to the power of I pi is -1. So then I pi plus 2 pi I k, because any multiple of 2 pi I is going to land you back. Yeah, you can just factor this if you like. I'm doing this in more than one step because I don't really want to make a mistake. So e to the power of I pi, and then that's 1 plus 2k, where k is any real number. Any positive integer. No, any real integer. Sorry, not positive integer, any integer. Okay, so let's continue on. Okay, r to the power of 4 is this 4e to the power. Now z is obviously you have to do this to the root 4. So then this is 4 root 4 e to the power of I pi over 4 e to the power of I pi over 4, 1 plus 2k. E sub k. Okay, and let's see, that's 2 squared, which equals to, okay, let me see, 2 squared for that's the square root of 2. E I pi over 4. One plus 2k. Okay, now let's just, there's going to be 4 solutions. Yeah. Z0 is equal to, let's see, root 2 e to the power of I pi over 4. Because this, it will just be 0 for the case. So yeah, root 2, that's 1 over root 2 plus 1 over root 2i and that equals 1 plus I. That's the first solution. Z1 is equal to root 2 1 plus, yeah, e I to the power of 3 pi over 4. Which equals root 2 cos pi over 4. Let's see, that's cos pi over 4. That's negative 1 over root 2 plus 1 over root 2i. And that's equal to negative 1 plus I. Z2 is equal to root 2 e I 5 pi over 4 which is equal to root 2 negative 1 over root 2 minus 1 over root 2i. I realized I made a mistake earlier. Sorry. I like this. Sorry. So sorry about that, guys. And this is equal to negative 1 minus I. And Z3 is equal to root 2 e I 7 pi over 4 which is equal to root 2. Okay, let's see. Yeah, that's 1 over root 2 minus 1 over root 2i. Which is equal to 1 minus I. Guys, I'm gonna take a second to write this down in my notepad. So I'm gonna pause the recording and I'll be immediately back. I just don't want to get lost because I know I'm gonna have to erase all this later when I start a new page. So yeah, I'll be right back. Hey guys, I'm back. So basically we have 8 parts to this, since this is to the order of 8. So y of t this is going to be equal to, I'm going to draw a line here. I don't want this to get messy. Directly plug in these values. C1 e to the power of 1 plus it plus C2 e to the power of negative 1 plus it plus C3 e to the power of negative 1 minus it plus C4 e to the power of 1 minus it. Now we have 8. We were required to write C 8 times. We only have 4. Where are we missing? Well, remember, we did r to the power of 4 plus 4 squared is equal to 0. So in like ordinary differential equations, when you have something like squared, then you have to put a t in front of it. Like if you're doing something like a side note, like y prime prime minus 4y prime plus 4y is equal to 0. You can think of the 0 here. Then it's C1, like, you know, this is r squared minus 4r plus 4 is 0. Then C1 e to the 2t plus C2 t 2e 2t to the power of 2t. So you have to do the same thing here. Yeah. So basically, we have to add t to each of these components now, multiply t. So then C5, let's start at the very beginning here. T e to the power of 1 plus it plus C6 e to the power C6t e to the power of negative 1 plus it plus C7 e to the power of negative 1 minus it. Sorry about that. C7 e to the power of negative 1 minus it plus C8 e to the t here, t e to the power of 1 minus it. Okay, y is equal to, now there's this theorem in ordinary differential equations. I explained it before. When you have this, when you have like this I e to the power of it, you can break it up into its real and imaginary parts, which would take the place of cos and sine, and they would both be like parts of the solutions to the differential equation. So this could be actually written as C1 e to the power of t cos t. Yeah, so e to the power of t times e to the power of it. Yep, cos t plus C2 e to the power of, let me think, e to the power of t sine t plus C3 TET cos t plus T4 C4 TET sine t plus okay, so plus C5. Remember, there was the 1 plus I and the 1 minus I. We have to do the, e to the power of negative t, e to the power of negative t cos t plus C6 e to the power of negative t sine t plus I have just enough space. C7 t et cos t e negative t cos t plus C8 t e to the power of negative t sine t. This has been by far one of the trickier problems you'll have in ordinary differential equations. But I am glad I solved it without a solution manual too. So that is all for today. Thank you very much for watching. If you liked the video, click the thumbs up. Yeah, I'd love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.